Okay, so let's talk about implicit differentiation. It's almost the same thing. Okay, don't let the food distract you. Alright, so let's say you want to differentiate y equals x squared. Yeah, it doesn't mean take the derivative. Alright, now it's your question. What's the derivative of x squared? 2x, good. Any questions there? No one's mind blown away? Good. Alright, now, this is where notation comes in. And this, the notation is important. We talked about this when I first introduced derivatives. And we always use, f prime of x or y prime, just because it's shorter to write, easier to write, and it's less to type out. So that's what we've been using. But is that also true? Yes. Yeah, you can also write dy over dx, and I did say that this we do use pretty often. So we actually don't just say the derivative is 2x. We don't just take the derivative of 2x. We actually take the derivative of everything. So we take the derivative of y also. Now, when we take the derivative of y, we write dy dx. Because we're taking the derivative of this entire equation in respects to x, meaning we don't need to write this. Then it's a dx over dx. And that's just 1. So we don't write it. But if we're taking a derivative of a different variable, then you need to write d of that variable over dx. Okay, so basically, if you're taking the derivative of y, you take the derivative the same way as normal, but every time you take the derivative of y, you do need to write dy dx. Okay, any questions there?
You have to do it on the test.
Yeah, because this won't be by itself sometimes. Alright, and then this still stands for slope, because it is the derivative. Still stands for the rate of change. It's the same thing. Alright, anyone still copying down? Alright. Okay, so this is implicit differentiation. So it's when it's not just, y equals or something like that. Well, you better be sharing that.
How much that was?
You better be sharing it with at least 3 other people.
Whoa.
Alright. So we're going to take the derivative. To take the derivative, we do, all the different rules and stuff like that that we know. So it's the exact same thing. So on this left side with the y squared, what rule are we going to use? Power rule. So this is going to be 2y, but we did take the derivative of y. So it's going to be 2y times what? dy over dx. Whenever you take the derivative of y, you're always going to need to write dy dx. And then the derivative of x is just 1.
Can you repeat that?
Yeah. Okay, so y prime is equal to dy dx. The derivative of y is dy dx.
So is that used as a variable? Or
Kind of. So we're going to do power rule here. So you bring the 2 down times y, right?
Yeah.
But it's just kind of like the chain rule. Now you take the derivative of the inside, except the inside is just y here. So it's times y prime, which is dy dx.
Are you going to be able to simplify that, or is that going to stay the same all the time?
You will simplify it.
dy dx.
Oh no, that will stay dy dx. So basically, whenever you take the derivative of y, or when you take the derivative of anything other than x, you do need to write dy dx, or whatever variable it is. That's why sometimes the question will say in respects to x. That's what this is talking about. It So if it's saying in respect to r, then when you take the derivative of r, it's just the normal thing. No, that's why it's saying in respects to r. When it's whatever it's in respects to, you don't need to do this part. But any other variable, you do. Yeah.
So whatever you do to one side, you do to the other side too?
You're taking the derivative of the entire equation.
Okay.
So it's not like, so it is like one side and the other side, but it's really just the whole thing. So derivative of the whole thing. Alright, any questions here? Now, we're not done yet. We did take the derivative. But we want to know what dy dx is equal to. We want to know what y prime is equal to. So we do need to solve for dy dx. So how do you get rid of 2y? Divide by 2y. Alright, any questions there? Alright, so find the slope of a circle at point 3, -4. This is why we need to know implicit differentiation. Because sometimes the graph or the equation that we're asked to take the derivative of is not a function. Where this is a circle, it's not. How do we know it's not a function? Yeah.
Vertical line test.
Yeah, because it doesn't pass the vertical line test. Wish I had a smart board. Yeah.
Can you remind me what a vertical line test is?
Yeah. So the vertical line test just tells you if something is a function or not. So let's say that's our graph. You can draw a vertical line anywhere and it will only hit the graph once. So this passes the vertical line test. So this is a function. But if the graph looks like this, here it touches it at 2 points. Because it does not pass the vertical line test, this is not a function. Alright. So here's the equation of a circle. X squared plus y squared equals 25. To find the slope of something, what do? Find the derivative. Good. So let's take the derivative of this. So we're just going to take the derivative of everything. What's the derivative of 2x? Oh, sorry, x squared. X. I find whatever. Okay, derivative of x squared is 2x. Good. It's not really a mistake. I was just asking you what the derivative of 2x is. If anything, everyone got it wrong because the answer was 2. Okay, so derivative of x squared is 2x. All right, everyone okay with that? What's the derivative of y squared though?
2y.
Good. 2y dy dx. So anytime you take the derivative of y, you do need to write dy dx. Now, when you take the derivative of x, you actually could write dx. So this is 2x times dx over dx. But this is just 1. That's why we don't write it. Plus, derivative of y squared is 2y, and we took the derivative of y, so it would be dy over dx. But this doesn't cancel out, that's why it's still there. This does cancel out, which is why you don't see it. Okay, any questions with this before I erase it? Yes, and the derivative of 25 is 0. Okay, any questions with the derivative? So we just did the derivative. Yeah?
So it only occurs when the beta is y?
Say what?
The
dy over dx?
yeah.
Only write that when you take the derivative of y.
Can
Yeah.
you move the x squared to the other side before you do the derivative? Okay.
Yeah.
That's what I did.
That's fine. Yeah, you can just leave it there for now. Just leave it there for now. Alright. Now, what do we solve for though if we're looking for the slope? Yeah, dy dx, right? The derivative. Dy dx tells us the slope. So go ahead and solve for dy dx. I always drink Coke diet.
Really?
Yeah, you'll never see me drinking regular soda.
That doesn't taste like it now.
It's not that it tastes great.
Are you on a diet?
Nope. But don't get a buy like this by drinking regular soda. Alright, so this is what you guys should get. Let me move this out the way. Alright, any questions there? So you subtract 2x, divide by 2y, and it does simplify to negative x over y. Do I have that on the...
Oh,
Man.
What? Thirsty? Alright. Any questions there? Okay, now we do need to find the slope at a specific point. So what do you think we do? Plug what in? Good, the point that they give you. So what do you plug in for x? What do you plug in for y? So that simplifies to 3 over 4. Does the negatives cancel out? So what is the slope of the circle at that point? 3 over 4. So let me draw the picture for you. Or actually, why don't you draw a picture, draw the tangent line to it, just a sketch, and then compare with the person next to you and see if you guys get something similar.
Use a graphic calculator.
No, just do a sketch. You should be able to know, because you just found something, you need to know what you just found. We don't do this stuff just to solve for things. We always do it for a reason.
Oh, we found the radius.
We did not find the radius. Well, you gave it the radius. What did we just find? The slope at a specific point. I don't know. Okay, so that's a good place to start. The circle. Yeah, a little. I didn't do it yet. Alright, compare with the person next to you once you've drawn your tangent line. And see if it looks similar. Because we found the slope of the circle at a specific point. So we should be able to draw a tangent line at that point. Alright, so this is what you should get. So there's 3, negative 4. We just found the slope of the line of this circle at that point. So the slope of the line is 3 over 4. So you should be able to go up 3 to the right 4. There's your tangent line. That's what we just found. The slope of this tangent line. So if you zoomed in on your graphing calculator at that point a couple of times, it should look like a straight line with the slope 3/4. Because it's at this specific point. Right, so it's not just the slope of the circle at any point, it's at that specific point. Because even slightly to the right of it, the tangent line is different. Yeah.
What are the points inside the circle?
Like here?
Yeah.
That won't happen. Because it's going to be the slope of the line at a specific point of the circle. Alright, any questions? Okay, so that's what we just found. We found the slope of this line right here. The slope at this point. Right there. Alright, any questions? Okay, so you should be able to figure out, you should know what we're looking for at all times. Alright, go ahead and find the derivative of that. Okay, here we go. So, I think that's right. You kind of got to think of it like the chain rule. So whenever you take the derivative of the outer function, you need to take the derivative of the inner function also. So derivative of 2y is 2, but since we took the derivative of y, you need to write dy dx is equal to derivative of x squared is 2x. That's okay, we don't need to write anything.
2x. Oh yeah, good.
Derivative of sine y is cosine y. Now, here, it's kind of like the chain rule. That's why you practice the chain rule so much. Y prime is equal to sine of y times y prime. So the derivative of y prime is dy dx again.
You did right. I did right.
Oh, I got it right.
Yeah.
Wait, why did you put sine y? Shouldn't it be the derivative of sine y?
You kind of
Yeah. Okay, any questions with this? Someone?
No.
No. We just took the derivative. Now we need to actually solve for dy dx. So, let's put all the dy dx on the same side. We have 2 dy over dx minus cosine of y dy dx is equal to 2x. How do we get the dy dx out of there?
Divided.
Distribute.
Simplify.
You don't distribute it.
It's
You don't expand.
Factor.
You factor.
Oh, it's
Good.
called factoring on my bad.
Yes, you factor.
I messed up my terms.
Yeah, you did. You factor the dy dx out. So we factor the dy dx out. What do we have left?
I messed up.
Yep, you did.
Wow.
Alright. And then divide both sides by 2 minus cosine y.
I got that first.
I got that first.
Oh,
There's your answer. Dy dx equals 2x over 2 minus cosine y.
I told you. You didn't say anything. You got it wrong. You're like sine. You got this part.
Yeah?
We're almost halfway to getting brownies.
Almost.
Oh yeah, we're probably gonna get another one.
But I'm making less and less mistakes as the day goes on.
yeah.
Exactly.
Dos manos.
Okay. So last example. I will give you guys 2 assignments. This example is going to take a little longer though, because we are writing an equation of a line tangent to something. Alright, anyone still comments down? Alright, so to do this, what do we need to do first? What? Differentiate? Yeah, we need to take the derivative first. When in doubt, take the derivative.
That's fine.
Yeah.
I'll be ready.
Yeah. So that's Janice's slogan, and it actually works most of the time. If you're not sure what to do, just take the derivative. You'll probably be right.
When in doubt, divvy it out.
Yeah.
That's better than yours.
No, it's not.
Yes, it is.
No, it's not.
It actually rhymes.
Mine didn't rhyme on purpose.
When in doubt,
Okay, so let's take the derivative of this. Derivative of x squared is this just
One.
dy over dx.
nope. what's going on between x and y? It's multiplying. So you have to use the product rule. Alright, so you're going to put the minus there. Let's open up some parentheses. We have x times the derivative of y. What's the derivative of y? 1 dy over dx. Plus y times the derivative of x, which is 1. So that's okay. Alright, so it's not that bad, right? It's not like life is over. It's just this. Plus, derivative of y squared is 2y. Good. dy dx equals what? 0. Any questions with that? So, the x and y, you do need to take the product of that. Alright, so let's distribute the negative. Let's move the stuff that does not have dy dx to the other side and leave the stuff that does have dy dx on the left side. So we're going to minus 2x plus y. So minus 2x plus y. If it's not working, then that's fine. I can always.
No, it should work.
I couldn't find the driver either.
I can't find the driver. Let me see if I may have the driver.
Solid. Okay. So what do we do here?
Factor.
Factor out what? Factor out the dy dx. Whatever they have. Okay, so you factor out dy dx. You have negative x plus 2y left is equal to negative x, negative 2x plus y. And then, yeah, you divide it. So dy dx equals negative 2x plus y over negative x plus 2y.
I'm wondering if you hardwire it, if you just actually
Use it, plug in the USB just so that I can
just
tell
to
the
see
driver.
it, because I know that happened to me just a few minutes ago. He can connect with the
Okay.
Ethernet.
Okay, I can do that then.
Okay, I'm going to try this one last time.
Okay, that's fine.
Try it and then.
Alright, so any questions so far? What do we do now? Yeah, Ricky?
Can you make it 2x minus y over x minus 2y?
You could. Wait, say it again?
Could you make it equals 2x minus y over x minus 2y?
2x minus y over x minus 2y, yes. Alright,
Wait a second.
so we're still trying to write an equation. To write an equation we need the slope, and we almost have the slope. How do we figure out the exact slope? Yeah, you plug the numbers in. So I'm going to rewrite this as m, because we know that that's going to be our slope. You can leave it as dy dx, that's fine too. Let's plug in negative 1 and 2, so we get negative 2 times negative 1 plus 2 over negative 1. Please don't mess up the negatives here. 2 times 2. That's going to be 2 plus 2 is 4. 1 plus 4 is 5, so 4 over 5. Yep. Any questions there? Okay. That's the hardest part. No, not this, but this. That should not be hard.
That's the one.
Okay, now that we know the slope, and we know a point, can we write the line tangent and the line normal? Yes. Go ahead and do that yourself. You should be able to do it at this point, because we've been doing it for the past 3 or 4 tests. You have 2 days to do it. Let's do it. 2 days to do it. Alright, so this first one would be tonight's assignment. The second box would be tomorrow's assignment. Okay, so you can bring your book or take a picture of it or whatever, but this is what you guys should be doing in class tomorrow. To do this one tonight, because these are simple problems that you will be taking the derivative of. And these are a little more complicated.
That's okay.